I know we didn't do the construction yet. I'm going to do tomorrow is dedicated to all constructions. All right, so we are going to do this angle bisector construction in class tomorrow. Did I show you what an angle bisector was?
Yeah.
Okay, so we got through that, right? Cuts an angle into two congruent angles. So now my question is, did we get to example one? We did example one together, right? Okay, so it looks like I'll start on example two then. All right, so just a refresh from Friday, because it's been a while. This diagram, you are told that Kn bisects LKM, and remember, definition of a bisector is cuts an angle into two congruent angles. So that's why many of you have these arc marks there, because you know Kn is a bisector. So those two angles are congruent. We did example one. Now we're on to example two. Here we go. NKL, everyone find that angle and label it 7x minus 9 for me. NKL. These are new values. Those two angles are still congruent in example two. We just have new values for the angles now. All right, so example one's done. Clean it up. The only thing that remains is the angle bisector. So we have 7x minus 9 right here. And we have JKM, which is x plus 3. All good. All right, now we got to find some angle measures. How many degrees in angle JKN? All right, right now, can I just set these two equal and go? No, I don't know they're congruent. So I got to do... Here's where you guys got to start becoming the honors level. And that is, most of the time, I am not going to provide you with enough information. You might have to add something to your diagram that you know is true. Because right now, x plus 3, 7x minus 9, all by themselves, don't do me anything. I can't use them just by themselves. So is there something else you can add to my diagram right now that you know is true? Josh?
Like the line JKL is equal to 180 degrees.
Okay, so Josh, I'm getting a step ahead, but I'll talk about it. JKL, everyone agrees that's a line, aka a straight angle. We called it on Friday, equals how many degrees? 180. So Josh, I think what you're telling me is if I combine all three of these angles, they'll add up to 180. Is that what you're telling me? And everyone agree with that? If I add all three of those angles, they add up to 180. But I got a problem. I only know two of them. Oh, or do I, Ian? Why can I put 7x minus 9 on that? They're congruent, so that's 7x minus 9. There's my missing link. Now, yes, going back to Josh's point, x plus 3, the first angle, plus the other two congruent ones, add to 180. Do we see that? We okay that why they add to 180? Put all three together, they form a straight line, measures 180 degrees. Please also, because I always see this even from honor students every year, 180 degrees is only for angles. All right, for some reason, I'll start seeing it like we're doing a midpoint problem or all of a sudden people set stuff equal to 180. Only if we're dealing with angles. All right, go ahead and solve. I shouldn't have to hold your hand here now, right? Solve, plug it back in, and let's find the measure of JKN. So we should be finding x equals 13, plugging that back in appropriately, because you're going to have to, looks like, substitute it in for two angles. You're going to have to substitute that in for two angles to find JKN. So you substituted in for JKM and got 16 degrees for that angle. and then you substituted in for MKN and got, oh boy, here, 82 degrees. So total JKN should be 98 total degrees. All right, looking good. You and your group, all by yourselves. Not going to say a word about this one. Thank you. Number 3, all by yourself. Work with your group members if you'd like. Got to draw a diagram from scratch. Equation, solve it, plug it back in. I guess just like rolling solo, huh? No conversations. Come on, that's got to change. We got to pull through together here. You guys can talk. No need to whisper in here. Let's go. Let's go. Be confident. Be proud. X equals 15. And then you guys are plugging it back in to find BAX. So 5 times 15 minus 25, that should have given you 50 degrees for the angle, 15 for X. Okay, all set? And we'll do the angle bisector tomorrow when we do all the constructions, all right? Any issues here? Okay, now I want to transition over to the homework. All right, let me just tell you what I'm going to do with homework because I don't know, and this is not to your fault, how much effort was put into it because I didn't finish the notes. All right, so that was kind of unfair for me just to say, hey, go do the homework without knowing everything. So here's what I'm going to do. I'm going to go over this diagram in particular right now. I'm going to give you the opportunity tonight to show me actual greatness and not a hot mess, which might be that right now. All right, so I want to just go over a few things with this diagram, and then if you need to clean up anything tonight, show more work, then do that tonight, and I will check it tomorrow. All good? Okay, so I'm giving you another night here to show me some greatness on this homework, and just not a couple lines that maybe you think is correct or incorrect. Because I feel like now that we just finished the notes, you have a better understanding of bisector and setting up equations. But before I leave the homework, though, I want you to notice, I don't know if you noticed this in the diagram or not. This is the diagram straight from the textbook. Do you see what's already given to you guys? What do these arc marks mean? So the book is already telling you those two are equal to each other already. So I don't know if you guys noticed that or not because it's kind of small in the book, but those two are congruent. And, what is that? And in the directions, it also gave you another fact. BH bisects EBC. So take a look at angle EBC up here. That angle is being cut in half into two congruent angles by BH. So not only are those two congruent, does everyone see another pair that has to be congruent? BH is a bisector. EBH is congruent to HBC. All right? So I want to make sure you were aware of that before you even tried to tackle this problem. All right, so if you think you're all set, you don't need to do anything tonight, but I appreciate it, though, tomorrow when I come back and start walking around, you know, I see 2s plus 22 plus 2s plus 22 equals 8s minus 16. And we're solving that. That's what I want to see tomorrow when I walk around. Equations set up and solved appropriately. Good deal? We're all set? So I'm going to walk around and check two homeworks tomorrow. This one we just talked about and the one that's going to be assigned tonight. All good? Okay, let's get into, I hate to break the news to you, but last day of vocab, which is good, but a whole bunch more today. All right, a whole bunch more coming today. First one off today, let's do this. Adjacent angles. When are two angles adjacent to each other? Well, usually when you hear the word adjacent, what comes to mind? Yeah, next to. Anybody that says that, hey, I live adjacent to this guy or family, all right, you live next to him. Okay, a little bit more though. I need a little bit more when it comes to the angles. And the definition is there, but I'm going to extract three things that need to happen. Three things that need to happen for two angles to be adjacent. First thing, they got to share a vertex. What do I mean by vertex again? What's the vertex of an angle? That's where my two rays come together, right? That's the vertex. So both angles need to have the same vertex. They also need to not only share a vertex, but they also need to share a side. They have to have a side in common, or a ray in common. And then the final thing here, it's not going to make too much sense, but it'll make a lot of sense when I show you the first example. No interior points in common. I know that makes zero sense, but I'll show you what I mean here in a second. So all three have to happen for two angles to be adjacent, all three. All right, look at diagram A. Let's figure out, are angles X and Y adjacent to each other or not? Ready? Let's go down the list. Do they have a common vertex? Do they? Yes, they do, definitely. Do they share a side, a ray? Yeah, the one right in the middle there. All right, ready. Here's what I mean by no interior points in common. Put the compass down. It's a distraction. We're not needing it today. Here's what I mean by no interior points in common. Everyone right now, take your pencil or pen. Put a point inside angle X. Somewhere, put a point inside angle X. Is that point also in angle Y? No, it's not, right? Okay, put a second point inside angle X. Is that point in angle Y? No. Hey guys, is there any point you could put in angle X that will also be in angle Y? No. So that means they have no interior points in common. See what I mean by that now? All right, no interior points. So what can we say about X and Y?
They're adjacent.
They're adjacent. Perfect. They're adjacent to each other. All right, next up, diagram B. What do we think about those two? Adjacent or not? Well, let's go down the list. Do they share a vertex? Okay, let's stop talking then. Who cares about the other two? If they don't have the first one, they're not adjacent. All right, last diagram. And I just want to make sure all of us are very clear on what is angle X and what is angle Y. Ready? Angle X is the full angle. The full angle. That's why I had that full arc mark there with X on top. Angle X is the full angle, while angle Y is this one. There's angle Y. All right, so are they adjacent or not? Ready? Do they share a vertex? Yeah, they do. Right there. They share that vertex. Do they share a ray or a side? Right here. 2 for 2. 2 for 2. Ready for the last part? That point is in angle Y, and it's also in X, so they do share interior points. So that would make them not adjacent. All good? On adjacent angles. All right, let's keep piling on the vocab. I think you guys are familiar with these next two. Two angles that are complementary add to 90. Whoa, 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 whoa. This may have been glossed over back in the middle school, but it's got to be 2. Well, Mr. Carlino, what if I have 3 angles and they add to 90? Anybody know what you call 3 angles that add to 90? 3 angles that add to 90. That's what you call it. Complementary is only for 2 and 2 only. All right. Let me show you the high school diagram that you'll see. The honors level, big boy, big girl. 1, 2. I put no degree measures on that, but how do I know those two are complementary? Look at that diagram right there. I put I didn't put 40 and 50. I didn't put 70 and 20. So how do I know 1 and 2 are going to be complementary? Add to 90. Talk to me. What do I have on there? Oh, 12. Olivia, what do I have on there? Yeah, I got the right angle symbol, which tells you what? Right angles add to, or what? 90 degrees. Perfect. All good? All right, so I got complementary, adds to 90. I have supplementary, adds to 180. Make sure we get those straight. Here's a nice diagram that has no degree measures, but somebody's going to tell me why they add to 180. Angle 1 and angle 2 are supplementary. How do I know that? I don't have 180 on there. I don't have any angle measurements. But how am I going to know 1 and 2 are supplementary? Talk to me here. 9, what's up, Ian? 1 and 2 form a line. Lines add up to 180 degrees. Good job. All right, so we're good here. I think you guys are pretty familiar. I just want you to see a different diagram. All right, next one. I don't think you're familiar with at all. Linear pairs. Linear has the word line, right? Line in it. Yes, 2 angles that do form a line, but they have to be adjacent to each other, everyone. All right, so that's what a linear pair is. 2 angles, forms a line, has to be adjacent. Diagram A, what do you think? Or 1 and 2, would I consider those linear pairs? Are they adjacent? Let's go back. Are they adjacent?
Yeah.
Yes, but do they form a line when I put them together? 1 and 2 only, not all 3. 1 and 2 only. No? Good. So they're not a linear pair. 1 and 2 are not a linear pair. They do not form a line. How about B? Does that look like a linear pair? What do you think? Yes or no here? Linear pair? 10. Matt?
Yeah.
Yep, they are. They are. Ooh, how about C? Would C, do you think, be a linear pair?
No.
What's your thought? Yes, no? 9. Ian? No. Well, first of all, are they even adjacent? They don't have the same vertex, so they're not even adjacent. So forget about if they form a line or not. Oh, big moment right now in your math careers here, or your geometry career. Theorem. Before I write in anything, what is a theorem? What's the only one you probably are aware of? Pythagorean theorem, right? Here's a theorem. It's a true fact in math. That's what a theorem is, a true fact. And I'm not trying to scare you. I'm just being real with you. Probably as far as theorems go this year, we'll probably have anywhere from 40 to 50 theorems total this year. I'm going to show you 2 right now. Here's your first theorem of the year. First true fact in geometry. Linear pairs are, and we're going to help me fill in the blank right now. What do you know about linear pairs so you can help me fill in the blank? There's multiple answers here, but I'm only looking for one to fill in for the theorem. What do you know about it? Linear pairs are? What could you fill that blank in with? Nothing? Nothing at all. We just never just talked about this.
Adjacent.
Adjacent, they are. That's not what I want to fill in, though. 100% correct. Okay. Keep going. What else do you know? Gianna? Yes. Give me a better word. Give me a word for that then. Congruent. They add up to one. You just told me they add up to 180. What type of angles do that? Not congruent ones. Add up to 180. Supplementary. If you know two angles are linear pairs, you know that they are supplementary. Okay, they are supplementary. Good? All right, next up. Some people in my third period honors class knew these, some didn't, so it doesn't matter. Vertical angles. Vertical. You can only have vertical angles if you have two lines that intersect. Please don't copy this down, just take a look up here. So vertical angles are only formed if two lines intersect each other. How many angles did I just form up here, kids? 4, right? The vertical angles are the ones opposite each other. Okay, so 1 and 3 are vertical, 2 and 4 are vertical. What are 1 and 2? Talk to me, come on. I'm quizzing you already. What are 1 and 2? Those are supplementary, linear pairs, adjacent, right? What's 4 and 3? Supplementary, linear pairs, right? They're all linear pairs, supplementary, except for the opposite ones. Those are vertical. Okay, those are vertical. So in part A, would 1 and 2 be considered vertical? Angles 1 and 2 in diagram A, vertical or not? 4? Doyle, vertical or not? No. Nope. But for a little bonus here, what are they, Doyle? Good, because they are?
They're on the same line.
I want a term.
They add up to 100.
I know that. I want a term because they are?
Supplementary.
Yes. And why are they supplementary? Because they are? Linear pairs. Good. All right, trying to pull some vocab out of everyone. What about B? Ooh, what about B? Everyone thinks opposite, but how are vertical angles formed? Two intersecting lines. Are any of those even lines? Absolutely not. They don't measure 180. So those are not vertical. And then how about part C? What about that diagram? 1 and 2 vertical, yes or no? 5. Haley?
Yes.
Yes, good work. Those are vertical. All right, so what do we know about vertical angles? We knew linear pairs are supplementary. What do you think I know about those? Well, you guys will find that out for me right now instead of me giving it to you. Let's say angle 1's 100. You should be able to find all 3 angles now. All 3 missing angles based on what we've discussed today. So if angle 1 is 100, tell me another angle you're pretty confident in based on everything we've talked about today. 3, Aiden?
2 is 100.
How do you know that?
Oh, it's 80.
There you go. Good. More. Give me more. Yeah, keep going.
3 is 100, and then 4 is 80.
What do I know about vertical angles? Look at the verticals here now. Look at the angles we said were vertical. What do you know about if 2 angles are vertical, they will be, give me a word. 9, Ian? Congruent. There you go. There's your fact. There's your theorem. If 2 angles are vertical, they're congruent. So vertical angles are congruent. Also, a quick discussion here, spelling. Spelling in here. Vertical, commonly misspelled word in here for some reason. It's C-A-L at the end, not C-L-E like barnacle. Okay, it's C-A-L. Have some self-respect. All right, let's try to get that correct. Well, is he going to take off for it on a quiz or test if I spell it wrong? No, absolutely not. I might write you a little note about maybe reevaluating your life here. Let's spell this right. Okay, so I might do that. All good. My 2 theorems. All right. Final word here before we start practicing a little bit. Perpendicular. Here's what I think about. I hear perpendicular, right angles. I hear perpendicular, right angles. Okay, perpendicular lines always form right angles. So give me two lines right now that look like they form right angles and intersect each other. What are you going to put on your diagram to show me that a right angle is formed? Hopefully not the number 90. The box, right? And why don't we put some names to these lines? So how do I write this mathematically, right? Because we always want to write stuff symbolically. Name one of the lines for me so I can write it down. 5. Here you go, Haley. Name one of those lines for me. Okay, so we know how to write that now. By this point in the unit, we better. Line CD, and what's the other line? 14, Gianna? Line AB. All right, now, how do I write that they're perpendicular? Anybody know that symbol? No one's got it today. You guys are my last hope. Anybody know the perpendicular symbol?
Is it like two lines and a cross against each other?
What are we playing, tic-tac-toe?
No, like it's like a line and then a line, like a plus sign, but like line.
Not equal to?
No, like arrows.
I don't think we're getting it.
All right.
All right, good try though. Amy?
So like an upside down T.
We have a winner. Yes, we have a winner. There it is, everyone. Perpendicular. Basically two segments that look like they form a right angle, right? So anytime we hear this word going forward, what's being formed? Right angles. Right angles are being formed at the intersection. Yes. Good, everyone. All right, so here we go. Talk to your group, please. Talk. You guys are going to do 1 through 6 right now for me. 1 through 6. Do not go on to 7 or 8. Go ahead, 1 through 6 in your group. Using that diagram, find those 6 angles for me. You got this. 14. Just lost my cheat sheet. Gianna, go ahead. Start us off right. What do you got for me? 51 is a good start. Number 2, EBA. 5, Haley. 90. That was a tough one, huh? Yeah, right next to the other, adjacent to the other right angle. Number 3, DBE. 2, Zoe. 17. You guys are rolling. Number 4, 12, Olivia. Buck 7. ABF, number 5. 9, hearing from everybody. Ian. 141. Let's finish this strong now. Number 6, DBF. 2, Zoe, back to you. 68. Good work. All right. Any issues? Want to see any of those? Okay, moving on. Word problems. I know your favorite. 2 angles, complementary. Everybody stop. Stop. What do you know about these 2 angles if they're complementary from today's discussion? 6. Thomas, what do we know if they're complementary? So I have 2 angles right now up here. 2 angles that add to 90. It's just a matter of what the heck do I fill in those blanks that represent the angles. Let's keep reading. Degree measure of the smaller, 50 less than the degree measure of the larger. Find each of them. Find the larger. Usually you start these word problems off by calling something X, then building off of that. So we need to make a class decision. Do I call the smaller X or the larger? There's no incorrect response, but it will affect how we write the second one. So do we have a class decision? If the degree measure of the smaller angle is 50 less than the degree measure of the larger? Anything you want to call X in particular, smaller or larger? Smaller or larger? Larger. Everyone all right? We'd go larger. Okay, you could call the smaller one X. I'll just talk about how that changes things. I do not require let statements at all. All right, I do not require them, but I like to write them down, and I'll show you why at the end of the problem. So we'll call the larger X. So then what's going to be the smaller then? How do I write 50 less than this one? 50 less than. Oh, 14, going deep, Gianna. 50 less than. Yeah, be confident. You're good. Now, roles are reversed. Let's say we called the smaller x plus 50 now would be the larger one. All right, x plus 50. All right, let's solve it up. 2x minus 50 equals 90. Add 50 to both sides, you get 140. And then go ahead and divide both sides by 2. X is 70. And this is why I like let statements. I know what that represents now. I'm not trying to figure out, oh, is it the smaller? Is it the larger? I'm not guessing. I know it's x is the larger. And then what would be my smaller angle up here now? My smaller one, 6. Finish it off right, Thomas. 20 degrees. And how do I know I'm pretty much almost locked in to be correct? What do these add to? 90, complementary. All right. Good there. Oh, I love this next one. Two angles are supplementary. Stop right there. What do I know about them? If they're supplementary. 15, Gabby. They add up to 180. So again, here are two angles, blanks here that add up to 180. Let's figure out what we're going to put in. All right, no larger and smaller, more 50 less than here. Only thing we know about the two angles, they're in some ratio of 7 to 2. What's that mean, that they're in a ratio of 7 to 2? Well, it could mean that one angle is 7 degrees and the other is 2 degrees, 7 to 2. Does that make any sense in this problem? No, because they have to add to 180. All right, well, I could double them, because if I double them, they're still in a ratio of 7 to 2, right? Does that make any sense? 14 and 4. No, that certainly doesn't equal to 180. All right, well, what if I triple them? 21 degrees and 6 degrees. That's in a ratio of 7 to 2. Make any sense? All right, I'm getting tired here of doing this. All right, and we shouldn't have to guess and check like this in an honors level class. We should be able to come up with some type of method to put in our equation so that they'll equal 180. Now remember what I was doing. I was doubling. I was multiplying by 3. I'm trying to have you guys figure out, what do I need to multiply 7 by and what do I need to multiply 2 by, so when I add them together, I do get that 180. So how can I show that in my equation? What do I multiply 7 by? Well, what am I going to put with it then? I don't know it. X. What do I multiply 7 by? And the same thing, I'm going to multiply 2 by. So what am I going to put with the 2? And x as well. Does everyone see? What do I multiply 7 by? And the same thing by 2 to get with the 180 at the end. So here we go. 9x equals 180. X equals 20. Be careful. Is one of my angles 20? Is one of my angles 20? No, that's what I'm multiplying by, right? That was that number, not 1, not 2, not 3 here, but by 20. So go back, plug it in for me, and let me know what the larger and the smaller angle is here. All right, do you have the two angles for me when you're ready here? 4, let's go, Doyle.
140 degrees and 40 degrees.
Good, 140, 7 times 20, and 40 degrees, 2 times 20. And do they add to 180? Yes, they do. They're supplementary. Good job, everyone. Good work. And then I think we'll have it. Yeah, we got 4 minutes. We got time. You're in your groups right now. Go ahead and do number 9. I'll put my work up here to finish off class. Great session today. Please read all the givens.